Hi, hello everyone. So last time we created this kind of quad and then just texture it, and I promised this time we're going to look at elementary buffer or index drawings, if you will. And what is that? First, we kind of have to understand problem with this old kind of drawing, and the problem is as follows. Take a look at, for example, let's see here. Uh, let's look at this, how it is made. So we had triangle, right? This is one. All right. We had this kind of triangle, right? And then the second one as well here. And the problem with this is, so when we specify our vertices, we had for first triangle, let's see, v1, v2, and then we might have v3. But for second one, we had to duplicate this one, right? So we had to have v4, v5, and here v6. And you can see it exactly here, right? We had left top once, left top twice, and then also for right bottom, right here and right here. So you can see the problem. We end up duplicating a lot of vertices, and the thing is, it gets even worse. The more the complex, so it gets even worse with complex models. Let's just that we have some simple cube, and let's say that our cube triangle is here. This is 1, 2, then up here we might have 3, we might have 4, and then we might have even here 5 and 6. And you can see this vertex here, it actually needs to be referenced 6 times for each of these triangles, right? Here, 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 here. So it and because it's also for 3D, we need to store x, y, and come on, z variables. So it gets even worse, and that is a lot of data. And the more complex model is, this even gets a bigger issue, right? Because just to store this kind of data, we need to duplicate a lot of vertices. And how do we avoid it? Well, it's easy to avoid it actually, and we can just use ElementArrayBuffer. And how this works is basically, let's take a look at our quad example once again. So we still have to draw 2 triangles, but instead of doing it like previously, we might have just v1, v2, v3, and v4. And then how do we draw it? Well, we just specify indexes. So it might be 0, 1, 2. In programming, you kind of go from 0, so that applies here as well. So this will define our first triangle, this one. And then for the second one, we might use v1, which is 0, v4, which is 3, and v3, which is at the index 2, right? Just to figure this out, just lower this guys by 1 because that's programming for you. And it same applies if it's cube, right? We're just going to define this, for example, point once, and we might reference it a couple of times, but as you can see with the references, we just have a single number instead of defining x, y, z once time, then x, y, z second time for the same vertex. We just define, okay, use it here, here, here. Anyway, you get the idea. And so how do we create element array? How do we create those indexes? Well, for start, let's just get rid of what we don't need. And this left bottom is dupe, we don't need it. And right bottom is dupe as well, we don't need it. So let's say, what did I say, left bottom, right bottom. And that's the thing here as well. You also save this on this data because you can get rid of additional data, and that's why. And even here, right, color buffers. You can see here how much of the data are we saving here. And how do we create this element array buffer? Well, the same thing that we did with this one, create array buffer. It's not going to be of type array buffer, it's actually going to be element array buffer. So we can say create index buffer, that's probably good. And then we can say here create buffer. We can store the buffer, but we need to bind the buffer, and then we just need to store the data. And here we're going to use uint16 array. We're actually going to change it a bit later. But let's just now see, store it as unsigned integer 16, that's integer of 2 bytes, right? 2 bytes is 16 bits. Okay, and so now that we have it, we actually just need to create it here, const index buffer, and then we can say these are probably good suggestions. I assume we can say 0, 1, 2 and 2, 1, 3, and then the last step that we need to do is we're not drawing arrays anymore, we're drawing elements. Draw elements, still triangles, and let's see what does it offer. We're drawing 6 of them. Type is unsigned short, and then offset is 0. If I save it, it's here. All right, perfect. So let's see what we did here. What did we do here? So for example, we have left bottom texture coordinate. So we have v1 here, then we might have left top v2 here, then we have right bottom v3 here, and then we have right top which is v4 here. And then let's look at the indexes 0, 1, 2. So this one, and this one. So that's one triangle. So what did it say? It said something else here. 0, 1, 2. That's first one. And then we had 2, 1, 3. So this is 2. This is 1, and this is 3. So that's the second one, and that's how it's drawn. So the second one is 2, 1, 3, and that's how it works. Also, now since we have that, we can just optimize it a bit further. As you can see here, maybe, where are you? Let's see. Exactly here. We paste uint16, but we can also just paste uint8, and then it doesn't work because we also have to say here unsigned byte, and now it works. So this is going to be use bit less data, but as I mentioned previously, we can just store up to 255 indexes, and we can optimize actually this like this. We could say uint8 array. It can also maybe be uint16 2 array, and then we can just say, all right, I don't need this. We can just say here data. Perfect. Maybe I should just enlarge this for this part. Let's see. Okay, and now we just need to change it here so that we pass here, for example, new uint8 array. Perfect. And that should generally work. And it does. One more thing that I actually wanted to refactor while we're doing that. Let's actually do let's do same here. We're just going to pass actually float to array, then we can get rid of this. We can just say that it's always going to be 432 array, and then it fails because we just need to do this. All right, that's for colors. We need to say it here. And here as well. All right, and that's it. That's how indexes work. Hopefully see the benefit of them. And for the next time, I think we might cover these arguments here because we haven't used them so far. And this is really useful because you can essentially merge all of this data into one buffer. And we're going to do that next time. So hopefully you enjoyed this video, and until next time.